Originally, I thought this was a 45-minute talk. I cut it back this morning, so we've got 20 minutes. I'm going to talk a lot about DDoS testing, what the ROI is for organizations doing this. Of course, first of all, we got to understand what the problem is. What is the problem that you're trying to solve? I've been personally involved in this area for the last decade. We've redefined the way the problem can be solved. The damage is getting more significant as people become more reliant on online services. The more the damage is apparent to every organization. Understanding what the solution is to the DDoS problem, if you have a need to prevent damaging downtime, you need to understand how that can be done. What is the process to get that done? We talk about continuous testing, the onboarding process of a typical customer and what it looks like, and the practical deployment and value that you get from such a solution. This is attributed to Einstein. He said, if I had an hour to save the world, I'd spend 55 minutes defining the problem. So, and then you've only got one solution, you're going to find the best solution, right? So what is the problem? What is the problem we're solving? Essentially, if you're an online company and reliant on online services, if you're a bank, an insurance company, a payment processor, a government, an airline company, anything that can stop your business continuity, DDoS is the #1 threat to stop your business continuity, that's what we're trying to prevent. That's what organizations that have DDoS protection and online services are trying to prevent with a DDoS attack. And of course, there's a huge eventual financial impact on that. DDoS protection is not fully automated. It's something that there's a huge reliance on a manual component to prevent damages once they're already occurring. What you want to do, especially in the advent of AI, is get out of any kind of process that has any manual reliance in the actual philosophy of that defense. So what's the current state of DDoS protection? If you look at a typical enterprise, you go, you buy one or more layers of DDoS protection, you do an initial configuration. At some point in the future, you have some downtime, you have an emergency response to that attack, you analyze what's going on, how the attackers were able to bypass your defenses, you apply another configuration in the security policy. You then might do some red team testing that you say, okay, I just had some downtime, maybe we should do a red team test, figure out how an attacker was able to bypass my defenses. You reconfigure stuff again based on that data. The vendor recommends typically adding more layers of DDoS defenses, add this layer, add that layer. Eventually, an organization sometimes has downtime again. This is the cycle that we've seen over the last decade, and one of the reasons we get organizations coming to us is they don't want to be in this cycle, and that's why they take on non-disruptive testing. The challenge in DDoS protection is that these manual procedures mean security weakness. Any manual procedure in any security process is typically, if it's for your defense, if it's for initiating your defense, a manual procedure equals security weakness. There's limited visibility on how to configure security policies, so you have to have a reliance on this manual procedure to know when an attack bypasses you. You've then got to go figure out how it bypassed you, apply that, because you had no previous visibility on how attackers could bypass you. And that's because DDoS protection is very complex to configure. So sometimes what happens is you over-harden those services, you have false positives that you're unaware of that can actually degrade digital services in your organization. Any manual procedure requirement cannot prepare you for current attacks, and it cannot prepare you for AI-enabled attacks. Traditional DDoS testing is what people tried to do in the past. The benefits of this is that it does check your human procedural response and understand when a damaging attack comes, what you do to actually start preventing that attack. We did a survey recently of 300 CISOs from the BFSI, banking financial service industry sector, that 78% of the CISOs they see that disruption to live services is a big problem with traditional DDoS testing, The test results are outdated quickly, and there's limited attack vector coverage. They require maintenance windows, very low coverage. There wasn't even one organization that uses traditional testing that can cover more than 200 attacks. Your typical organization, in order to do full attack surface coverage to see how attackers can bypass those defenses, requires tens of thousands of attack simulations. There's little to no remediation value with traditional DDoS testing because you almost have no data to harden your defenses. Red team testing can only get less than 1% of your actual attack surface. To fully automate DDoS protection, if you look CDN, SCP, CPE, those are all kind of different layers of DDoS protection that you can buy in the market today. And the visibility an organization has today is that gray. That gray is the visibility. The green indicates an attack comes to one of those layers and is automatically blocked. The red means it goes through that layer. You have to enact an emergency response, and then you apply a fix in the policy, and that will be blocked afterwards. So what the non-disruptive testing does is it brings this data to the organization to understand how effectively each layer of that protection works. Because you're able to run simulations all the time non-disruptively, not in a maintenance window, you can run thousands and thousands of simulations weekly and generate the data required to be able to understand how well your fully automated protection is working. Now, in order to actually get to automated protection, you need to first understand how do attackers bypass my protection, right? I need to understand how can an attacker bypass. The only way to do that today is by launching an attack and seeing if my defenses work. Without that data, I'll have the requirement of a manual intervention. So getting that data is the first challenge. Without that data, you cannot have fully automated protection. Once you've got that data, you need to remediate that data. And that's where there's other challenges that I'll get into that are involved. But basically, having fully automated protection, understanding how an attacker can bypass, eliminates the need for a manual process after that when an attack comes. The current situation of most organizations is this in the best case. When we get there, these are your various layers of DDoS protection. This is the level of visibility they've got on the left. Once we start doing non-disruptive testing, thousands of simulations, a typical chart looks like the one on the right. The automated, remember, anything comes to the green, it's automatically blocked. The red means it gets through, your online services are down, you've got an emergency situation on your hand. It shows you, this red, just to be clear, shows sometimes thousands of ways attackers are bypassing your defenses. So you can imagine if you're an org today, what do you have in terms of data to show what an attacker can do to take down your online services? There's probably not a lot if you're not doing this type of testing. Once you are doing this testing and you've remediated the red part, you're able to get to the right-hand chart, which is much more automated protection. To get from the left to the right, this is nice in a picture, but it can take quite a lot of, it's not a lot of work, but it's work, and it's a deliberate process in the organization to do it. What is the business process? So typical onboarding process for a non-disruptive testing program looks like you've first got to obviously clarify the areas of responsibility, who's responsible for IT infrastructure, who's responsible for all services in the cloud, who's responsible for those services, the uptime, the business continuity of them. On that, define a deployment plan, map the attack surface. Normally it's a hybrid of cloud and on-prem. The number of mitigation layers you've got, whether it's cloud WAF, on-prem WAF, CPE, scrubbing centers. You've got to initiate the deployment, get the deployment done. It has a detector on-prem, which works with the cloud. You've got to install the detectors. Your configuration, you've got to add targets. So the systems typically add targets automatically. So they will, if you've got 500 targets, they're going to, the non-disruptive testing system should go and get those targets by scanning for them based on definitions of networks or FQDNs. You've got to validate that the system is running. Typically, when you've deployed such a system, it's got to be non-disruptive. There's a period of validation where the system calibrates itself in order to be able to run non-disruptive DDoS testing against those online services. And then you've got to actually schedule when are these going to run. The organization gets asked in the onboarding, when would you like to run? Would you like it between 9 and 5? Would you like it out of hours? Would you like it on the weekend? Whenever, or can it be 24/7? We run with gaming sites, for instance, in our company, which are very concerned about latency. And we run during production. We don't see any type of latency issues. And really good non-disruptive testing should be able to run whenever you want. At the end, what we all need is a report. You need reports for your vendors of what needs to be fixed. You need reports for your executive teams, for your board or your security advisory board that reports to the board, and for compliance. And also we've seen that some of the payment processes that we work with actually get reductions in cyber premiums when they use our data to show risk reduction in their environment, because premiums are very expensive. Quarterly business reviews with technical account management is very important too. Customizing sometimes reports to show what is the progress, how much progress have you made, what is the value to our company. This is a typical case study. This is actually a European bank, which I would call more of a multinational bank, but they're a massive bank, more than 80,000 employees, over $1 trillion of assets. They're over many countries. This is a good example of we deployed in Q1 in one data center, and we started, the gray indicates what hasn't been covered yet, and the green is the automated protection, and the red is the vulnerable area. We started the program at the beginning of the year. By the end of the year, at the beginning, we confirmed 11% of automated protection. The 59% is still unknown. And by the end of the year, we had eliminated hundreds of vulnerable areas of the defenses. Sometimes if you've got a few hundred vulnerable areas in the defenses, you just need a few fixes. It will knock out hundreds of those areas of vulnerability. Over the year, we were able to get confirmed to 74% automated protection. And that I'd consider good in that particular environment. We were working in this case with Radware and Arbor. Arbor was the cloud scrubbing, and Radware was the on-prem. In DC2, we started in Q3. We were able to confirm. Now, keep in mind, these graphs here represent thousands. It represents thousands and thousands of simulations, right? So this is really confirming for every service more than 160 attack vectors trying to hit that service, can it get through or not? That really confirms if your automated protection is working or not. That data is prioritized, and the red is knocked out as quickly as possible with our managed services helping to do that. An interesting thing that we found in this particular case is when we started running, we saw in the original onboarding of the system functional test, we found some weird. Before you run the overall program, you do some tests to check that everything is going to function well so that there'll never be disruption. We found some weird behavior, that there was some deviation from, when I say deviation, I mean milliseconds of deviation in monitoring times of services when we were running our tests, and we were cutting in under 100 milliseconds in this case. And what we found was that there were legacy configurations in the Radware settings, in the policies. They have quite a complex setup in terms of the way they did it, and it was blocking 100,000 legitimate requests daily of transactions, of actual transactions. When we removed that, this is the graph actually that was shown to the executive team there. You know, cumulatively, they were able to, in a short period of time, they had let through an additional 9.3 million legitimate transactions, which actually improved the digital experience of the customer. The overall benefits of this type of program: you're validating your DDoS defensive readiness, gaining measurable reduction in your DDoS risk, fully automated protection, all quantified. You've got all the reporting you need for your vendors, for your executive branch to show that improvement throughout the year and continuously. And your ROI is significant. Of course, what you want to do is you want to prevent a damaging attack at all costs if your online services are relevant for your business continuity. So going back to the original chart that I showed you, what happens when you've got a DDoS, an ongoing DDoS testing capability, you deploy your defense, you have continuous testing that checks and eliminates vulnerabilities in those defenses. You identify all the ways that attackers can bypass, and every time an attack comes, the idea is that that protection is automated. So if you look at a market today, if you have a typical enterprise today, what you've got is you've got the chart on the left. The moment that you apply, so there's an inherent need for manual. This red means that if you've got protection for your online services, that red means that you are waiting for a damaging attack. It means that you've accepted as an organization that if you get hit by a DDoS attack, you will have first a significant damage and then bring in an emergency response. Organizations that have enabled a non-disruptive DDoS testing program are on the right. If you're a bank, when you start a program, at least with our company, you're typically on the left, or an insurance company, or later on, as the year progresses, you start to get more towards that right-hand chart. And the speed on the right, of course, is dependent on how quickly you're remediating those vulnerabilities.